Good evening, welcome. Nice that you all are here this evening. My name is Gerwin Smit and I'm an associate professor at the Department of Biomechanical Engineering here in Mechanical Engineering faculty. And I will tell you about the track Biomechanical Design. And well, maybe you've already seen it. Some of you might have seen the video of last year, and what I'm going to tell is quite similar. So, and later this lecture will also be recorded, so later on you can also see it back. In the video there's still my predecessor, but I'm the new coordinator of this track. Mechanical design is of systems that either interact with the biological system, and often that's the human body, or apply principles from biology, which is bio-inspired design. Is everything fine? Yeah? So that means that the core elements of this master track are biomechanics, and then control, how are you going to control this biomechanics, and design, how can you design new systems that either interact with the human body or with other biological things, or design mechanical things for mechanical engineering that are inspired by biology or by human anatomy. The topics that I will cover are the curriculum, courses and topics, and some questions that we often get is what is the difference between this track, BMD, and between BME and between the Master Robotics. I will inform you on admission and bridging possibilities and where to find the info, and to give a little bit an idea on what you can well, do after your graduation, what kind of career options you have. First, curriculum and courses and topics. So here we see the entire curriculum of the first and the second year. So the first year, this is about courses mainly, and that consists of 3 groups of courses. We have the obligatory courses that are obligatory for the track. Then we have some mechanical engineering core courses from which you can select at least 2 courses, and those are the same for all mechanical engineering tracks. And then we have some design project courses, because design is an important aspect of this master. Well, and then furthermore you can select from a broad range of electives. You can select some individual courses that you find interesting. So you see that you have quite some space to create your individual program. Now the second year, it's more about applying what you have learned in the first year. So you have, it starts with the first part is the internship. Well, the second year, first part consists of 15 EC, quarter of the year. So that's the internship, but alternatively you can also choose the joint interdisciplinary program, project, or you could also choose to fill this 15 EC with more electives, although that's not highly advisable, but if you want you can do that. Most people choose the internship and then they go to either a company or some other university, and then they get some external experience. Then the second part of the second year consists of your graduation project. Your graduation project starts with a literature study, so that you are now diving into a certain topic, and then of course you need to read a lot and read what has already been done before you start reinventing the wheel. So you establish the state of the art, and then you build further on the state of the art and well, come up with some new things, either develop new knowledge or develop a new design. Now, so if you want to know which courses are all available, then you can go to studiegids.tudelft.nl, studyguide.tudelft.nl, but it's the Dutch link. And then you see all the, if you select the tab and select the Master Mechanical Engineering, you see the different tracks here. And then you can find all the courses, the obligatory ones and the elective ones. And you can find information on the, the content of the different courses. Now, okay, what can you expect in about the content and about the projects that you can do, for example, for your graduation project? What kind of research are we doing within our, maybe, yes, thank you. As I mentioned, we design devices that are inspired by nature, and one of the famous examples is this laparoscopic, maybe that one, I think, yes, that's the video, so I hope that is, no. This is a laparoscopic gripper or a laparoscopic device, and it can move like the tentacles of an octopus. And there's a long-lasting, long ongoing research line. And this research line is about developing new devices. And it started off with relatively large devices, but they are also now really miniaturized. And here you see an example of a small gripper device that can be used to perform surgery within the eye. And it is steerable. Yeah, it's but that's a really challenging task because everything is, of course, very delicate. And there are some other really cool inventions and innovative designs that are, for example, based on the needles of a wasp. What is the name of the wasp? The ovipositor. No, I cannot recall pronounce it correctly, but some of these wasps, they have a very long needle, and they can put their eggs a few centimeters below the surface. And this needle is entirely steerable, and recently our research group developed new needles based on that. Then there is also a long ongoing research on prosthetics and orthotics devices. Prosthetic devices are replacement of parts of the body that are lost, and orthotics are parts that, for example, like exoskeletons or braces that support the function of a limb that is still there, but that's, for example, paralyzed. And then we have developed, I myself focus on the design of prosthetic devices, and one of the devices these days that we have are 3D printed, and some of these devices that we've developed are also available now on the market. This was another example that I did together with my colleague Heike Valerie, who's also a professor in our department, and a very large group of students and staff members. And we developed during the COVID crisis a low-cost ventilator that could be produced anywhere in the world, and it was based on a design from a museum. So that was a kind of temporary project that we did. And during that time, there was also a lot of activities of other colleagues and research groups who were working on solutions to be used for the COVID crisis. Then there is a lot of research going on surgical graspers. So one of the things that is also really important in the design of surgical grasps is that they have to interact with very delicate tissue. You don't want to damage the tissue if you grasp it, and these grasps can be used, for example, for keyhole surgery. And it's also important that you can easily clean these devices. And and then there is the ongoing debate whether such devices should be disposable, you use them once and throw them away, or that you reuse them, and then you have to take them apart and sterilize them. And in the past decades, we have seen a trend from more and more complex devices that were single use. So then you just need to sterilize them once after fabrication. You use them and then you throw them away. But now we see that there is an increased need for complex devices that are also can be used again and again. So what things will you learn? You will learn about mechanisms in nature, because there are many examples. We even don't know all of them yet, so we can learn a lot of that. And how translate this bio-inspiration to systems that we can use. And that's not a one-to-one translation. We are not going to exactly copy nature, but we try to understand the underlying principles, and then which is usually with other types of materials, and then we work usually with different types of materials and try to use these principles for our devices. And then it's really important that you think of a force distribution in mechanisms, and these devices should be safe to use. And then courses could be bio-inspired design. So how can you translate this, what kind of inspiration can you find in nature, and how to translate this into mechanisms, in mechanical engineering. But of course you will also need to learn about anatomy and physiology and biomechatronics, because if you want to design things that have to interact with the human body, then you at least need to know the names of all the body parts, and of course you know all the names of the body parts, but you might also need to talk a little bit with doctors or read the literature, and then they use all the Latin names. So we need to learn a little bit about anatomy, but there are also courses that are more engineering based, like compliant mechanism, design of compliant mechanisms, or about precision mechanisms. How can you design mechanisms that are really precise? And of course 3D printing is also really important these days. Now, and then what other example projects do we have? This is for example a gyroscope, and the idea is that if you have balance problems, for example for elderly people, or for people who otherwise have balance problems or muscle weakness, they have difficulties maintaining their balance, and they might fall. Now, of course, you can prevent people from falling if they walk with a walker or with crutches, or you could tie them with a rope to the ceiling. But all of this is not wearable and not really practical. And then there was this idea of one of my colleagues who said that, okay, can we use gyroscopes? Because if you have a very extremely fast spinning wheel, and you start twisting it, you can create torques in different directions, and by doing that you can create a force. And this force you can use to stabilize the person. So here you at the right side you see a test setup with one of the first gyroscope prototypes, and you see that the person is pushing, and then because there's just a single joint below there. So normally, if the gyroscope would be turned off, it would fall to the left or to the side, right. And now this gyroscope is stabilizing the system. Well, this was the first version, and the newer versions became smaller and smaller. Another example is the design of a cable robot. I mentioned in rehabilitation centers you often have this strap to the ceiling and then people can walk back and forth, but usually then they can walk only along a line, and this line is then also half slack or it's hanging behind them, and that hampers their motion. And ideally you want to have something that supports you in the full area, and that is always well, just tight enough but not too tight, and it can also possibly give you some gravity support so that you, for example, only carry half of your body weight. And this was realized by a smart design of 4 cables, and then with an ingenious system with trolleys and motors, it could be positioned everywhere. And we now have, in our lab, we have this system, and this system also has been commercialized and is currently used today in multiple centers worldwide. Other things you will learn is to design and to simulate and to control robotic systems. One of the things is modeling the human body and the brain as a control system. One way, for example, is one software that's often used here is OpenSim, and one of the founders of OpenSim is also working within our department, and still working on further development of the software and how it can be programmed so it becomes more user-friendly. Other things could be wearable robotics or rehabilitation robotics. You can think of systems that help you to rehabilitate. Usually people now do physical therapy, but they could also be supported by a robot during the rehabilitation process. And here you also see some other courses that are focused on that. Other research topics that we have is we have an entire research line about bicycles. Very important, of course, especially in the Netherlands. And one of the research is now on stabilizing the bicycle and also preventing elderly people from dropping off their e-bike, which happens a lot. And then there is very exciting research on elite sports like ice skating and rowing, but also all kind of other sports. Often asked question is, what is the difference between biomedical engineering and biomechanical design and with robotics? Well, the important thing is that we are, with biomechanical design, we are a mechanical engineering track, which means that you are a mechanical engineer at the end, werktuigbouwer, and that will also be on your diploma. With biomedical engineering, you are not a mechanical engineer, and it is more medical. And then there is robotics. So what is then the difference with robotics? Well, this is led by the cognitive robotics department, and this is really focused on the cognition, so the brains of the robot, and much less on the mechanics of the robot. So we are a mechanical engineering track. Well, we roughly have about 70 new students per year, of which 30% are women, and about 20% are international master students. But these numbers grow a little bit every year. So are you admittable, and or do you need maybe a bridging program? information about that can be found at our website. And it really depends on, on your background. Are you coming from a Dutch university? Are you coming from mechanical engineering? Or if you are coming from an international university outside the Netherlands? And then if you come from a Dutch university, which is not mechanical engineering, then you can see all our bridging programs here from the HBO. So you, this is also on the website, the same website, studigids.nl. There's also another website that shows our other bridging programs, and then there is a schakelcoördinator, a bridging coordinator, and you can send an email if you have specific questions. So there it says bridging program. Yeah, and this is the website, the email address of the schakelcoördinator. Now, once the course is finished, what are your career options? Well, like any other mechanical engineer, there are a wide range of well-known companies that are available, like the big ones, but also the smaller or the very tiny ones, like startups. Some people also end up in consultancy, management, and government. And another option is go to do research at a university or a research institute, like for example TNO. And what kind of occupations can you have, like application engineer, biomechanical engineer, business analyst, business consultant, business developer, constructor. Well, many, very long list. I'm not going to read all of them. And below it gives an impression of some of the companies that our people end up. For more information, you can visit our website. There's also the information about the bridging programs. And you can send an email to the schakelcoördinator, the bridging coordinator. And now the floor is open for questions. Thank you. Questions?
Can I ask in Dutch or should I?
Yeah, you can ask in Dutch. I will repeat the question.
Weet u toevallig of productontwikkeling, een masterproductontwikkeling dan in Antwerpen, of dat je dan direct hier naartoe kunt gaan nadat je de master hebt afgelegd? Of dat je een schakeljaar ertussen kan doen?
So you ask, you do currently, once you have finished your bachelor program, a master program,
Yes.
productontwikkeling, and then, that's not a mechanical engineering course.
No, I think it's more design.
Yeah, it's more design. So probably if you don't have a mechanical engineering background, you probably need to do a bridging program, because like the hardcore mechanical engineering courses should be on your list, like kind of like dynamics courses, all the more hardcore math courses, calculus, things like that, algebra. For the bridging program, the bridging programs are always shorter than one year. They are usually less than 6 CEC, and then but yeah, it might take you 1 year to finish them, but it's less than 6 CEC, and it really depends on your background how many ECs you need. Yes. Ja.
Maar stel nou dat je bijvoorbeeld vakking haalt, is het ook mogelijk om in februari te beginnen als sommige masters hebben die optie wel?
Yeah, is it possible to start in in February. Yes, that's possible, but logistically, it's you have some more challenges. But yeah, there's no rule that says that you cannot do that. And I think, yeah, Jorik, you also organize startup sessions for especially in February, so you can also well, receive some information on starting up around that time. Other questions? Yes?
How may a graduation project differ from the ones from the design track of BME?
How could they differ from, how could a BMD design project differ from a BME project? Well, there could be similarities. A project could be similar, but it could also be more a BME project could be more medical, for example, and a BMD project could also be more mechanical engineering. So it could also be a really mechanical engineering assignment in which you, for example, use a bioinspiration to solve the problem, and then it has nothing to do with medical, and that would be quite unlikely for a BME assignment. Other questions? If not, then thank you for your attention, and well, Jorik and I will also be available for questions later on, and you can always mail us and or mail the Schakel coordinator. Thank you.